Networking concepts in Kubernetes. Pod-to-pod networking. Every pod gets its own unique IP address. Kubernetes networking model, all pods in the cluster can communicate with each other without NAT, network address translation. This is achieved via the Container Network Interface, CNI, plugin, example, Flannel, Calico, Azure CNI, AWS VPC CNI. Pod-to-service networking. Pods are ephemeral, their IPs change if restarted. Services give pods a stable DNS name and virtual IP, cluster IP, for consistent access. kubeproxy handles service load balancing using iptables. Service types. Cluster IP internal-only service, accessible inside the cluster. Node port exposes service on each node's IP at a static port. Load balancer provisions an external cloud load balancer. External name maps service to an external DNS name. DNS in Kubernetes. Core DNS runs inside the cluster and automatically creates DNS records for services. Ingress networking. Ingress is an API object for HTTP/HTTPS routing to services. Requires an ingress controller, example, nginx, Azure Application Gateway Ingress. Supports host-based and path-based routing. Network policies. Network policies define rules to allow or deny traffic between pods or from external sources. Node-to-pod networking. Kubernetes, logs, and monitoring agents need to communicate with pods. Node IP plus pod IP mapping is handled by the CNI. External access. Service of type load balancer, cloud provider pound, or ingress controller exposes services outside the cluster. Port mapping. Container port inside the container. Target port the service forwards to inside the pod. Port the service exposes internally. Node port on each node's IP for external access.